Hello, everyone. My name is Dr. Corey Petty. Let me add my presentation to the screen here. You should be able to see that now. I'm Dr. Corey Petty from Status IM. I am the CSO, the Chief Security Officer of Status, and today's talk, I'd like to talk about the concept of self-sovereignty and how that transforms online security. So Web3 does a lot of pushing the security to the edges, and people have a lot of responsibility for maintaining their own keys. And I want to talk about how that transforms the concept of online security. So first, talk a little bit about Status, what we are, what we do. We started out with initial coin offering on one of the earliest ones, I think maybe fourth or fifth of the larger ones in the Ethereum ecosystem, with an ambitious goal of bringing together the Messenger, crypto wallet, and Web3 browser onto a single platform. Namely, our primary target was the mobile application. So we wanted to provide an interface to the Ethereum ecosystem or the Web3 ecosystem on mobile, and amongst other things too. And we've done that. You can download the application now, but we've always had a broader idea of what we wanted to do. The mobile application just being kind of the entry point into what that is. More generally, we aim to provide software and infrastructure that allows people to communicate and organize while upholding their fundamental human rights. We believe that a lot of the Web3 movement is about giving power back to the people, having good quality distributions of power across those that contribute to whatever communities they're in, things like that. In order to do that, you need the tools and infrastructure that work appropriately for how those communities communicate with each other. So, and doing all this while really keeping in mind security and privacy and fundamental human rights of the individual. But this isn't a talk about status. This is a talk about security in this new ecosystem or concept. And I'm going to kind of try and explain this by explaining two different things and then bring them together. So first off is the concept of the pyramid of pain. This is a concept brought up around 2013 to try and discuss the role of the security engineer within an organization. And that is how you detect indicators on whatever platform you're monitoring and trying to keep safe, how you respond to those indicators, how fast you can respond to those indicators, and how efficiently you can respond to those indicators. And then in the process of doing so, how you deny attackers from continuing to attack your platform, right? So if you understand that concept, identify things, respond to them, deny that thing from happening ever again, that's overall what you're trying to do as a security engineer. And you think about that from an attacker perspective. You look at artifacts on the platforms you have, et cetera, et cetera, et cetera. And back then, it came to the realization that not all indicators are created equally. And if you look on the right, you see what's referred to as the pyramid of pain. The pyramid is indicators that you can find on your platform. And on the right is the difficulty it is for the attacker to change the behavior if that indicator has been responded to and no longer available to them. So we'll start up to, and as you move up the pyramid, it becomes more efficient for you to deny these types of indicators on your platform, and more frustrating or difficult for the attacker to continue continuing what he's trying to do. And I'll go through, give you a couple examples of this as we move up. So at the very bottom, you have your hash value. A hash value is something you can do to hash some type of piece of malware, a document, something to see if whether or not that particular problem is easily identifiable. So you can mash up a document, run it against a known set of pieces of malware, and get rid of it. You can always search for that really easily. And while that's very easy to find a piece of information and get rid of it and have a large database of known bad pieces, it's also trivial for the attacker to change the document, change the binary, change the malware, change whatever it is, to then remove it. So once you change any piece of any binary, any bit of data, something like that, the hash value changes automatically and they can't be linked. So you can remove these things and address the situation, but it's very easy for that attacker to get around. If you move up, You have IP addresses. And keep in mind, this is the view from a traditional security landscape, and we're going to talk about that here in a moment. But IP addresses. So if you can find specific types of IP addresses on your platform, and they're known to be bad, you can block them at the network level and remove that person at that IP address from continuing what they're doing. But once again, in today's modern society, it's easy and arguably trivial to get new IP addresses. So you're not stopping the attacker from doing what they'd like to do. And as you keep moving up, you get to network hosts. Domain names are obvious. You have to, they're a little more hard. They're kind of like IP addresses, but you have to purchase them. You have to register them. There's a little bit of a setup process, so on and so forth. Network host artifacts, that's something like a user agent. Things that get left onto your platform that you can see. And if by blocking these types of things, you're increasing the difficulty a little bit more. That is, they have to figure out how you did it, what you've done to stop them, and then they have to do a little more work to then change it. Maybe they have to recompile a binary or something like that. And if they're not capable of doing that type of stuff, then you stop them in their tracks. But more sophisticated people can get past this, so it's mostly annoying. You go up the step one more time. You have tools. If you're able to identify the types of tools people use, maybe that's a collection of some of the lower things in the pyramid, and easily identify and stop a particular software suite or a tool that attackers trying to use to do whatever they're trying to do, then you're making them go and relearn a new tool. You've taken an arrow out of their quiver, as it were. And the more you can do that, the more you can just stop an attacker down the pyramid. They're going to go somewhere else. At the very top, you have what's called TTPs. That's techniques, tactics, and procedures. And this is the very top of where you want to live. If you can find a way to stop an attacker from doing a specific thing, a specific behavior altogether, maybe all of the different tools that do this type of thing, then you're forcing the attacker to basically choose between two things. Either that is restart from the very beginning, from scratch, or give up. And more often than not, they're going to give up. And so the goal here, as a security engineer, when you're thinking about cybersecurity, is to deny as many of the things at the top as you can, so that you make it incredibly difficult for people to attack you, because it forces them to change their behavior to do so. And that's kind of what you're trying to do in the terms of traditional cybersecurity, is find ways to deny people and force people to change their behavior in order to bolster the security of whatever platform you're trying to protect. So we'll get back to this. The next thing I want to talk about are general software trends, or general trends in technology. And that is starting at one, cryptography is getting way better. It's becoming stronger. We have new novel schemes. We have improved UX. Arguably, the blockchain space has been a tremendous boon to applied cryptography, and adding a bunch of resources and finances and so on and so forth into figuring out how to make good cryptography easier to use, so that we can build it into the foundational layer. We have a lot, and we have the same thing goes for zero knowledge research. We're finding ways to build new cryptography schemes built on the foundational layer, such that we're upholding a lot more of the security and privacy, for that matter, of the systems that we're using. This is an incredibly important thing, and it's very important. And there's a kind of a double-edged sword to this too. And also there's quantum cryptography research, whether that's quantum key distribution, post-quantum resistant cryptography, or quantum cryptography itself. These things are heavily being looked into, and in all these cases, it's making, in my opinion, the last bastion of defense for the defender better. Cryptography is the last place where the overwhelming power is on the defender and not the attacker. And we're making that much stronger and easier to use, and built into the foundational layer of a lot of different systems. Two, software is becoming increasingly distributed, and this isn't just for Web3. This is across the board for traditional software. Microservice architecture has transitioned from kind of the monolithic app architecture, and you have a bunch of different things built on the cloud communicating with each other, which then lead to APIs becoming way more central. So you have a bunch of different interworking parts that work together to actually end up providing some service or resource or application to the end user. And that's distributed across the globe. So you can provide services to almost anywhere, on all the time, which has been really great. That has other implications as well. Distributed consensus research. Avalanche knows very much about this. In fact, it's the main fruit of what a lot of the blockchain space and Web3 has pushed, is development into and research and money into distributed consensus research and making it better and better and better for a group of disparate people to come together on a conclusion on any piece of information, which is an incredibly important thing to do, especially when you're talking about digital scarcity. Zero trust models are taking the idea that you don't just have a single point of authentication. You actually have a much more fine-grained authentication as you move throughout any given organization. So it's not just like, here's my key pass, I'm in the building, and I have access to everything in the building now. It's, I need a key pass to do anything I would like to do anywhere. And my permissions are fine-grained controlled to make sure that I'm never going anywhere I shouldn't be. And that's kind of a general model as it moves across to a more distributed software environment. Consequently, and with other global things, organizational structure has taken the same route, partially in response to COVID, as companies are forced to be remote and global. You then have to rethink kind of how companies work, produce things, have access control, think about security as they move from everyone goes to this building to everyone does whatever they want with whatever hardware they have. And so not only is the software becoming more distributed, but the people who are building this software is also becoming more distributed. We're having a virtual conference. That's part and parcel of the same thing. This is because we're building better digital workspaces like Slack and Discord. These things make it easier to do this type of stuff, Zoom, and it also is a reduction in physical overhead. So it's making it more cost effective to run companies. And finally, once again, this is not comprehensive. This is just kind of to give you an idea of what's going on in tech. Devices are ballooning, and the power of these devices is growing incredibly rapidly. 5G is making these things incredibly connected. And what we're seeing is technology is enabling previously underserved communities to leapfrog their infrastructure and become a contributing member of the global ecosystem, the economy, and helping and doing things, which is a really awesome but important thing. So to recap some of that, traditional cybersecurity is about securing the castle. If you look at what I talked about, and where a lot of the traditional education comes around cybersecurity is like, this is my castle, this is how I defend it. I'm going to build moats around it. But the landscape and overarching terms of technology is destroying the concept of a castle altogether. And the way in which we learn how to do stuff always has us the mind of like, this is the thing that I secure. And I'm going to bolster the security mechanisms on this one thing. And now I have control over it, and I'll dole out control as I see fit. But something I ask anyone whoever works for me, and the concept of people of talking about Web3 security is, how do we defend a castle if there isn't a castle? What do we defend? What do we think about? What do we talk about? And it's a very important concept. So what I'd like to do is think about, does the pyramid of pain still work in all of this? I think yes and no, right? There's similar things that work all together, and things are changing, and we need to think about how to redo this. And I'll try and be quick here because we're running out of time. So we still want to force behavior change. If you look at the top of the pyramid, you still want to make people change their behavior. You still want to try and find things that certain behaviors leave a footprint on and get rid of them, respond to them as fast as possible so that those behaviors are no longer valid. You want to make people change the way they work. And that's a really hard thing to do because people don't like doing it. Cryptography is also on the side of the user, right? This is awesome, right? Because cryptography is getting so much better, we can build systems that are fundamentally more secure and more private without the user having to do anything about it. They're just better served. And that's solely at the concept of better technology, better math, and better applied cryptography. Baked-in incentives help steer what is economically viable for the attacker. Because we have programmable money and digital scarcity baked into some of this Web3 stuff we're talking about, not only does the attacker have to figure out how they can do something, they then have to also figure out whether or not it's economically feasible for them to do it, which it makes them incorporate a much more stuff into how they figure out whether or not their time is worth attacking a specific target. And I didn't talk about this, but machine learning, interestingly, can probably help take some of the bottom part of the pyramid that's easy for an attacker to get around and automate the process so that we no longer have to try and take care of it. They just automatically get taken care of. And so maybe some of that stuff in the lower part of the pyramid ends up becoming useful again. I don't know yet. Things that are changing for the worse in terms of looking at the pyramid of pain. Monitoring becomes much more difficult as we increase the level of privacy at the foundational layer, as we give up centralized data hoarding and move a lot of that stuff to the ownership of the individual. It becomes much more difficult to figure out what's going on in network. If you take status, for instance, when we start to look, we purposefully try and obfuscate network traffic so that we can't tell you who's talking to who or what they're talking about. That makes it very difficult for us to then try and handle situations where we would like to stop someone from abusing the system or help local authorities figure out bad things that are happening across the board. We're giving up the right to have that data and to make the decision to do something about it. So monitoring in generally, as you distribute across this thing and don't hoard as much data, becomes more difficult. Users are more of a target, also because they're holding on to more responsibility. And Web3, ironically, forces them to change their behavior. And since we've already discussed how difficult it is for people to change their behavior, not only are we making attackers change it, but we're also making users, the people who are going to be using our systems, also change their behavior. Software stack, more complex and distributed, which you talked about. And as always, people suck at secrets. We have to figure out how to get people to effectively keep secrets and not expose them. So let's update the pyramid of pain. I don't know what to put here, but it needs to be updated in the context of technology today and what Web3 is doing in terms of software development. So send me your thoughts on how we can do this. I would like to know how we defend the castle when there is no castle. So in order to do that, tweet Pyramid of Pain with your thoughts and let's brainstorm. I appreciate your time.